Another method which is very useful in order to determine the order of a chemical reaction, that is actually half-life method. And this one of the good method to measure the order of chemical reaction by using the different expressions we have determined, we have calculated for different orders of chemical reaction. As we have derived this equation, this one is the generalized equation for nth order of reaction. That means the half-life of nth order reaction is inversely proportional to the initial concentration of the reactor raised to power 1 less than the order of a chemical reaction. As we have derived the equations for first, second, and third order reactions, specifically for first and second order reactions, the half-life of first order reaction is independent of initial concentration, and the half-life of second order reaction is uh, inversely proportional to the initial concentration of the reactor raised to power 1. So by using this generalized equation, we will be able to find out the unknown order of specific chemical reaction. But we have to use the basic principles of logarithm and mathematics, then we will be able to find out the order of that unknown reactions. Let us suppose that we have to check out the order of a chemical reaction. Then we have to find out the half-life for that reaction and the initial concentration of our reactants which are taking part in the proceeding of the chemical reaction. So if we know the initial concentrations and half-life of the reaction, then by using generalized equation we will have the answer. Then what will be the order of a chemical reaction? Okay, now another method which is very useful method, that is actually the graphical method. As we know, the rate of chemical reaction decreases with the passage of time, so the amount of products X, it is increased during a chemical reaction, and the change in the concentration of reactants and products will be helpful to find out the order of a chemical reactions. As we have determined different differential forms for zero order, first order, second order reactions, and also we can find out the expression for third order reactions. As you can understand, dx over dt is equal to k, that is actually for zero order reaction. Dx over dt is equal to k into a minus x raised to power 1, that is for first order reactions. And specifically for second order reactions, we have dx over dt is equal to k into a minus x square, and for third order reaction, dx over dt is equal to k into a minus x cube. And these are the reactions when the concentration of our reactants are similar. So by putting these values, we will be able to find out what will be the order of chemical reaction. How we will be able? We have to take the dx over dt at y coordinate values as a y coordinate value, and for first order reaction a minus x will be at x-axis value. If we are getting a straight line passing through the origin, then we can confirm that this reaction is first order reaction. If we are not getting this straight line and the intercept is zero form, then we can say the reaction is not following first order kinetics. Okay, similarly, we can have a value of dx over dt at y-axis, and by putting the value of a minus x square at x-axis, and at the result, we are getting a straight line again passing through the origin. It will confirm the following of second order rate kinetics for our concerned reaction. Similarly, we can check out the order of reaction related to third order reaction for a generalized reaction or question reaction about which we are going to study. Okay, so both the methods like half-life method, graphical method, these are useful to find out the okay student, we have another method which is again a very simple method to find out the order of a specific chemical reaction, that is actually initial rate method. Actually, this method includes performing experiments separately with different initial concentrations. Okay, these initial concentrations of reactant, and we have to determine the initial rates, uh, as we know, log of which are plotted against the log of initial concentrations in order to find out the order of chemical reaction. So rate of a reaction that is started with some initial concentration of the reactants. This can be written like initial rate is equal to K into initial concentration raised to power n. Here n is the order of the reaction, K is the rate constant for that generalized reaction. Okay, by taking log on both sides, as in left hand side as well as in right hand side, then we will have another equation that is actually log of initial rate that is equal to n log of initial concentration plus log of k. So this one is the equation of straight line in intercept form, where log of initial rate is the dependent variable, and while the log of initial concentration is the independent variable, and we are taking it at x coordinate. Well, the slope of the plot of log of uh, initial rate versus log of initial concentration, it is equal to the order of the reaction, whereas the anti-log of intercept gives the value of the rate constant. So by taking anti-log of this intercept value, that is actually log of k, we will have the value of k, and by measuring the slope of the graph, we will be able to find out the n value, and n is the order of chemical reaction. So again, we have both the methods. We can find out the angle theta, and its value will be helpful, as well as the trigonometric method can be useful in order to check out the value of n, and this value of n will determine the order of